Hey everyone, welcome back to the shop. Today we're going to be detailing my homemade mill drill, all the accessories that go with it, and just kind of an overview of the machine, review of how it works, and possibly some tips and tricks if you wanted to do this project yourself. Alrighty, so here's the machine itself. It's a Craftsman 14-inch drill press, or at least that's how it started its life. Now I'll go over kind of the modifications that I did to turn that drill press into the mill that it is today. First up, I'll start with the XY table here. This is has an interesting story behind it. These slides here, these little sliding tables, they're actually, I have no clue where they're from, what they're for, or who makes them. I came across them in basically a scrap bin at a local makerspace, and they had no holes drilled in them. Like, I drilled all these mounting holes myself. They were just blocks of steel with dovetails cut in them that moved back and forth, and they're really actually nicely made. The ways are scraped in. It's got a great dial on there. There's almost zero backlash in the system, and because of the fine pitch on the threads, you can get some really tight tolerances when machining. But they were actually two separate sliding tables. There's the Y one and the X one. I've just mounted them together with a couple dinky little brackets here. You can't really see, but it's more than enough to hold it like dead solid. You can't move that around, so rigidity is not a problem. The vise on top here is actually a vise from a Chinese XY table, and this is how I started out the mill. I bolted one of these on the mill. It's obviously really just horrible. The whole thing is super loose. There's a ton of slop in it, and it's pretty much, oh, there's a clamp. It's pretty much unusable for milling purposes. It's just a not really well-made piece of Chinesium. That's what you call cheap stuff from China. But the vise was actually better than my old drill press vise over there, so I made some new mounting brackets and bolted the vise from that thing onto the XY table because it's relatively in tram, and it's a fine vise. Just the slide part was bad. As far as the rest of machine modifications go, here's what I did. So this has a very, I guess, unique system for a drill press. The whole head assembly, along with the column, moves up and down depending on how much I crank this. Like, instead of, because with the regular drill press, I'll grab the old parts. You got your table, and that table is attached on the column here, and as you crank the handle, just the table moves up and down. The head is fixed. So the way I made the head move up and down is I took this little, you can't really see, this gearbox here, because that's what the old table was bolted on. And I took that gearbox, took the table off of it, and you really can't see this, but it's welded to the base of the drill press. So the base and this gearbox are one piece now. The old rack from the rack and pinion system, I kind of tacked that on there with a couple welds. So now instead of the table moving up and down independently with the handle, the whole head moves up and down depending on how much you crank it. And the reason I did this is for rigidity. When I had the XY table on the old up and down table, what would happen is it would flex a ton, because this thing weighs like 50-60 pounds. So it would flex a ton. It just wasn't rigid because it was held on by one little bolt there. So it just wasn't really conducive to milling, because I mean, even when you had to move it up and down, you're cranking the whole, like, in total 80-pound assembly with this one little crank, and it was just impossible to move. So now you only have to move this like 30-pound head along with the motor, and it gives you a lot more travel like so you have more room here to mill bigger objects, use bigger drill bits. You have more travel, you have more rigidity. It's just an overall better system. So if you're gonna modify a drill press into a mill, I would advise you do something like this, or even find a drill press that works like this. Alrighty, next up we're gonna be reviewing the tooling and stuff I use, how well it works with the system, and maybe do a couple test cuts here. So first off, I just have your standard off the market end mills. Got a whole set of regular just 4 flutes and a cobalt rougher 1/2 inch. These are, for what I do, this is basically all you really need for cutting and slotting and doing milling stuff. I don't need any fancy carbide ball nose crap. I mean, well, it's not crap, but for me, this gets the job done. Next up, we kind of got some homemade cutters here. This is a homemade fly cutter, or it's a very small fly cutter, obviously, but for surfacing larger pieces of material, this does a great job. I have a broken end mill, which I kind of ground a radius onto and sharpened. So that is a really great little tool for surfacing stock. Here we kind of have this is a circle cutter without any means of measuring the radius, but it's a circle cutter. Could be a fly cutter if you put a different tool in there. That's just another thing for cutting stuff. Here, this doesn't get used as much. This is a little indexing head. It's a drill chuck I put onto a little machined piece of steel here with some dividing nuts in miscellaneous places. So what you can do with this is put, say, like the nut and the vise. You have something here, you mill a flat, you can rotate it exactly the degrees you want, like exactly 90 degrees or 180 degrees, or you got a hex on there, so you have divisions down to 6. So it's good for making little, basically anything hex shaped, or if you want 2 sides to be symmetrical, this is a good little trick for that. That's how I machined this little nut here. You can see it does a pretty good job of dividing. This is just kind of the box of tools, or tooling, I guess. It's mostly just broken drill bits and high-speed steel, or tool steel, broken wrenches, whatever I find that could be used as tool steel, I throw in this box. Here's a piece of a hardened steel bushing, absolutely indestructible, so that's why I keep that around. Here's a little, actually a lathe bit. I'll talk more about what you can do with those later. A little carbide tipped drill for drilling hardened steel. But yeah, it's just kind of where I keep all my tooling. Here's a little diamond grinding wheel. What this is, what I use it for at least, is I put a little bolt through so you can chuck it up in the mill, and I use this just for sharpening stuff, grinding. I guess the surface grinding, I guess you could call it. It's not the proper use for a mill, but as you can see, I'm not really about proper tool usage here. This isn't really a mill accessory per se, but it's just my calipers. Sometimes you can use them as like a DRO if you want to get like really precise measurements when you're milling. You just put those in there and you get like dead on precision if you don't trust the dials. But there's that. There's the aforementioned Chinesium XY table, piece of junk, and here's the old drill press table, which is no longer used, and I kind of use it like as an angle block now. But yeah, that's kind of all the tooling that there is for the mill. Now I'll talk about kind of operations and specialty operations, specifically lathe work. Alrighty, so here we are, kind of chucked up and ready to go to mill something, but obviously there's some stuff you need to do before you start, because drill presses are not meant for milling. Specifically, this is not the best quality drill press. So if spindle is, say, all the way extended, and I don't know if you can see this, but there's like 4 or 5 thou of slop in that spindle. The whole thing is, the vibrations are just crazy. If you try and mill with this thing loose, it'll vibrate out, maybe break an end mill. It's just not safe. So solution to that is, I have a little locking screw on the side. Keep a little hex key around for it. You just give that a little snug. So then the spindle is locked. You can't move it, but then the slop disappears. So it's much more rigid, gets rid of vibration, and it makes milling a lot easier. So what you would do, I'm not gonna start the mill because it's noisy, but obviously you can just crank that down, set your height. I really want to put like a DRO or something on the Z-axis, just to make it a little bit easier to check your height gauge. But very important thing to do is you gotta tighten the thing in the back, or else you have this whole head will actually like rock probably like 10 or 20 thou. It's not a lot, but it's noticeable, and that causes vibration. So you just snug that down, make sure everything's good to go, and now you're ready to mill. I'm not gonna mill, but again, that's just how you would do it. But there is a specialty operation I like to do with this thing. Let's say you don't need to mill exactly, but you do have something that needs to be turned down to a smaller diameter. What you can actually do is do some lathe work with the mill. So here I'll look through my scrap bin. Just a little chunk of brass here. What you can do is chuck like a piece of brass up in the old mill where you would put your cutting tool, but instead that's where you put your workpiece. And then you get, here's an example. This is a hex key. I ground a little tip on, sharpened it, and I use this as it's a lathe tool basically. So you put that in the vise, right? Not obviously, the aluminum's in the vise now. Right, you would put that in the vise, unlock your spindle, because vibration is not as big of a problem for this, and you go step by step, move your table forward, and you can take just nice facing cuts with this, nice diameter turning, actually, not facing cuts. But that's how you could do simple lathe work in here. I do that all the time. It's not good for huge pieces, but for small little diameter turnings, it'll work well. Here's a little kind of freehand taper I ground out, or cut into a little steel blank. But yeah, that's basically the operations of the mill, how it works, how you can use it for different types of operations, and yeah, it's a pretty good little tool. And I think that just about covers everything actually. I've covered your tooling, your mill. Remember, if you're gonna do this at home, I don't advise it, but you should definitely do the table modification, get some way to lock your spindle, and actually the proper thing to do would be replace the bearings in here. I haven't done that. That's on the list of things to do. Replace the bearings, table modification, and locking thing. Obviously XY table is important too. But yeah, hope you found this all interesting, and I'll see you next time.